Okay, this is example 2, 482. I'm actually just going to talk you through this one because this one would involve using either StatCrunch or Minitab or something like that to graph the histogram of a simulation. And so you would have to perform the simulation, which I went and looked at my Labs Plus. You don't have to do that. So instead, I'm just going to show you the simulations that they did and then explain. So if you look at the problem, based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the United States is getting worse. Describe the sampling distribution of the sample proportion for samples of size 10, 25, and then 60. So again, kind of like we did in 8.1, when they say a sample of size 10, they're taking as many samples of size 10 as they can, and each sample of size 10 is a unique sample of 10 people. So out of the entire population of the United States, they sampled 10 people, and then 10 more people, and then 10 more people, and then 10 more people. So this particular simulation was performed 2,000 times, 2,000 samples of 10. And then they did what's called a Bernoulli. So if you see that where it's a name, if you see that, that is what is used for this type of simulation, a Bernoulli simulation. And they got A. The histogram that they came up with was the histogram for A. So then they performed the same simulation again, and they got B. And then they performed the same simulation again, and they got C. Each time increasing the number of people in their sample size. So you can see, kind of like happened before with our normal distribution in 8.1, the larger the sample size, the closer it gets to a normal curve. So a few points that they make about it: as the size of the sample increases, the shape becomes approximately normal. That's what I was just saying. The center, the mean of the distribution, equals the population proportion. So you can see over here where the top point is, and it is not at 76. But as the size increases, you can see that pretty much my blue histogram lines up with my red normal curve. The mean of all of my samples comes out to be the mean of my population. And then as far as spread goes with the standard deviation, as the number increases, the spread gets tighter, the standard deviation decreases. So this is what the simulation would have shown you. The larger the sample size, the closer it is to normal, which we kind of already knew that, but what they want you to see is that it applies to proportion as well. All right, so for sampling distribution of p hat, another thing that they didn't mention here that is definitely worth making note of is you also, though, want your sample size. Your samples also, just like with binomial probability, they have to be independent of one another. So in order to assure independence in this type of situation, our n value, not only do we have the same rule apply, which is right here. Sorry, and there goes my dog again, y'all. I think she barks every time that I do a video. But not only does this same rule apply, but that we need it to be greater than or equal to 10. But in order, in this case, for us to assure independence, the other thing we want to make sure of is that our sample size is less than or equal to 5% of the population. So while you want your sample size to be large, you don't want it to be any larger than 5% of the population, because once you get it larger than 5% of the population, you start to get into situations where one is affecting another, and so it messes up independence. So those are two things that you have to make sure are true. So with all that in mind, for a simple random sample of size n with a population proportion of p, the shape of the sampling distribution is approximately normal, provided that this is true and provided that n is less than or equal to 5% of the population. The mean of the sampling distribution of p hat is the population proportion. So I'm going to say that again. The mean of p hat. So the mean of the sampling distribution is the population proportion. So if you know the population proportion, you know the mean, provided that these two rules are true. And then the other thing is, this formula is used to find the standard deviation of p hat. All right. Also notice this, regardless of whether or not the population, this value down here, regardless of whether or not this value is greater than or equal to 10, these two things are true. So it's just we can't apply normality unless this and this are true. But the mean and the standard deviation are found the same way, regardless of whether or not those two things are true. All right, so that's enough of this. I'm going to stop this and record a separate video.